The thing that I think that scares me the most, for a fact, this is going to change everything in the future. But the fact that in order to have this kind of model will become absolutely necessary. And the only people who can have the level of data and the level of compute is going to be big players. When I was thinking in my mind, I was like, you have to have the ability to innovate. You have to have this ability to build products. Like, it's always been this pattern of big companies grow up, become behemoths, move faster, cannot innovate, cannot do things. It spawns off these startups who then go and build these things. They innovate faster, do better. I just wonder if big guys are the only people that can really have the capability and money to run these things. And I also start wondering if it becomes so smart that it is the only thing that really helps innovate and helps execute. Do startups actually end up being at a disadvantage from big companies?
That part to me makes me a bit nervous. What's up, everyone? So welcome to another episode of AI Cybersecurity Podcast. Today is the second episode, and we're going to talk about from where we left off in the first episode. We started talking about Gen AI, but I had to hold Caleb back from explaining everything about Gen AI. But for people who don't know who we are, we've been talking about AI cybersecurity. We're both professionals in cybersecurity space. Caleb has been CISO for a number of years. I've been CISO as well. So we thought, why not talk about AI in a simplified way, lens on it for practitioners. With that said, Caleb, generative AI, we spoke about this. It's all the hype. What is it? What is Gen AI for people who've just been hearing about ChatGPT?
Let's start around LLMs. Okay, first, probably to say this is like the reason why we're doing this podcast is I did this presentation on me just learning through this journey, right, for myself. And I posted it for security people because I thought it was relevant, that it felt like a lot of security people focus on security, but not on just how an LLM works. And a lot of times, like, that's actually really important to understand how the engine runs. So let's talk about it. What's interesting, the amount of like material I had to go through, Ashish, just to get together everything that was enough simplified to where I felt like I could understand it was unbelievable. Like, it was really hard to find. Okay, I had to just go through all of these things to confirm, to get it to a point that goes, okay, I think this is right. And I think I can explain it and think about it this way. And so what I'm about to talk about is going to seem really simple, but actually took a lot of work to
Oh,
put
wow. Wait, before you start on that as well, because the question was more on Gen AI. Maybe is it worthwhile cementing that as well? Why Gen AI and LLM is spoken in the same tone?
Yeah. So to take Gen AI, when you look at AI, or at least machine learning in the past, they've been very narrow in their focuses, and they've been really focused on analyzing, predicting, but really analyzing and providing the information around, oh, is this a hot dog or is this not a hot dog? That's been the angle of things. The transformer, which really actually has been used for quite some time from my understanding, but this paper that came out, which is by Google and a couple other people, called Attention is All You Need, is about the transformer and how attention and being able to build context around NLP and how it works, and really changed the game in this. And so I'm a little fuzzy on how from the paper we ended up getting into ChatGPT, as I didn't really research the history of it. But all I do know is that paper was really a catalyst around where now you can take this thing and generate text at a level at which it makes sense. And so I think prior to this, just predicting the next word isn't necessarily that great. What do we call it?
Autocorrect?
Autocorrect per se, but
Autocomplete.
yeah, autocomplete, right?
Yeah.
Like, you can't, like, autocomplete by itself can't really make a lot of sense. But when you started adding this ability to create weights around context, around massive areas of text, and you have enough feature sets and the model gets big enough, and then you can also fine tune it to what you expect, amazing things get created out of it. Thus we get ChatGPT. But by the way, text isn't the only thing. So obviously, during the same time frame, things like Stable Diffusion started coming out, where you can start generating images and start looking at what that looks like. And a lot of this sort of generation, or this sort of Gen AI, started really taking off. And what you're starting to see, obviously, is this escalation of it. It's no longer just chat. It becomes chat, video, audio, photos. All of these multimodal capabilities are now starting to come into play. And I have this prediction of the evolving of Gen AI over the next, what are the next phases?
Yeah.
And one of I put up this column that's, hey, the way we interact with LLMs today are through text. The data that it uses is public data. And the role that it plays is about creating and informing, right? That's really the way we've been used to using this chat format. It's like replacing Google.
Yeah.
However, what we're moving into, I called it near future, but actually I think it's more today because I did this a couple months ago, but it's today, which is, it's not just about interacting with text. It's going to be about interacting through images, through audio, through video, even at the perspective of
Yeah.
Ashish. Like I'm just going to talk to an AI generated version of you, and that's going to be my assistant, right? That's going to be the way
Yeah.
it works.
Yeah.
And then the data is going to be, it's moving from public data to enterprise data and also to personal data, right? And then the way that it starts changing its role is I think AI starts becoming a decider and an actor. And when it starts making decisions and acting is when things get really fascinating. And actually, to further in this, my hot topic is around me playing with a project that where you give LLMs basically full root access and internet access and let it run. And you let it just make decisions and you just let it act. That's where I think AI becomes super interesting.
I feel like it's going to be one of those experiences like the self-driving car. When you said in a self-driving car for the first time, one of those companies like Cruise or whatever, it is so unsettling. The moment you said that, I had that unsettling feeling as well. I'm like, what? It can do, you're just giving
Yeah.
it root access, can do whatever it wants. Oh, I imagine
It's
there's some boundaries and all of that, but it just makes you feel like a bit more in the inside. You're like, oh, I don't know how to react to this.
it's like the first time you've interacted with GPT
Yeah.
and the amazement that you had.
Yeah.
And also the first time for me when I also saw or played with Auto GPT, or was it Baby AGI?
Hmm.
Similar, like this sort of automated sort of action thing.
Yeah.
And then I looked at this other thing, Open Interpreter, and I started running that. And I was like, oh my God, it's just getting more and more next level. And it's both amazing and
Yeah.
scary as hell. But the thing is, like, the benefits is far gonna outweigh any of the risks.
So you reckon that one paper that you just mentioned earlier, that's what's triggered all of this? Potential is all you need.
Yeah, I think that really gen the LLM aspect of, oh crap, like this is how you do it. It's also scalable through
Mm.
GPUs and being able to
Okay.
compute this way. I think both of those sort of combined in the ability to say, and the fact that they started building larger and larger models
Yeah.
also spawned a lot of this. For example, there's actually a slide I got to put in where they talk about how emergent capabilities come from model sizes, right? So the earlier versions were really neat, right? They were
Mm.
cool, like a little like auto
Right.
prediction, but okay, yeah, I can play with this. It does some cool things. But when you start getting into 7 billion, 50 billion, 70 billion, you start getting into these larger and larger sizes, these emergent capabilities just appear and nobody knows why,
Yeah.
right? Like
Yeah. Yeah.
it's just at a certain level of knowledge, all of a sudden, these things can like reason and make sense out of things that they were not trained to do or tried to be trained to do. And this is where it starts getting really funky. That's like really neat. It's super
Yeah.
cool to see.
So maybe if we peel a few more layers to this LLM thing, because I think you and I are probably equally excited. And my hot topic is about the whole meta AI thing as well. To get into it a bit later. The whole generative AI then. Obviously, Chat GPT became that first that exploded and then followed by Bard and all of that. Are they all
Oh,
the same?
definitely
And
don't forget about images. When you think about Midjourney and Stable Diffusion, those were also really early on too. And
yeah.
that was just
Oh,
one instance.
Dali, yeah. Yeah, Dali was there as well.
Dali
I think
was
there was
there.
a lot of automation for content as well, can generate text. Because you and I are both excited about this. So, what is Gen AI? After doing all that research, you got down to the LLM. What is LLM now?
LLM, obviously large language model, is this ability to predict text. And so I tried to say, okay, the simplest way for me to understand this is I need to understand the basics. And so how does it work? And so what I did is I did this whole presentation or this blog post as well. It says, okay, my example was let's just take a simple sentence. In apple tree. And I was like, what happens in an LLM when you take this? And so what it does is the first thing it does is it takes that sentence and it tokenizes it. And all tokenizing is is converting it to a numeric representation. And so every model has a different sort of tokenization pattern. I used OpenAI's tokenization. All it basically says is I need to convert words that we know of in parts of words into a number so that you can do math on it. That's
Right.
really what it's about. And so
Right.
you can take N, it has a number, apple, it has a number, tree, it has a number, right?
Yeah. Yeah.
Now you've tokenized this sentence effectively. The next thing is you got to think about this a little bit like a grid, like an Excel spreadsheet, right? So you take each word, an apple tree, and you
Yeah.
have it's actually represented by the numeric version, that number. And then think about you've got, let's say, all a columns, 4,096 columns or X number of columns per word, right? That goes in the row. And each of these columns are features for
Mm.
that particular word. For example, if you take the word apple, apple has 4,000x columns, and each column is going to include a numeric value in there that is now its weight or its feature,
Yeah.
right? And what
Okay.
does that mean? And so what it means is that each one of those columns is going to have some value in it that contains a little bit of information about that word apple. So let me give you a really simplistic example. You can have a positional encoding or positional value that says, let's just take one of those columns. Let's say the first column, just to be simple, and says the and word has the number one in it, the apple word has the number two in it, and the tree word has the number three in it. So now when you look at it, you can actually say, okay, that column represents the position in the sentence for that word,
Yeah.
right? Apple is number two because it's the second word in that sentence. Tree is number three because it's the third word in that sentence. So you can now see how a numeric representation can give you an idea of the context of the word in that sentence, right? Which is,
Mm.
oh,
Yeah.
tree is number three. It's the third word in that sentence. You might even, like, again, simplistically, now expand your mind to the context of every word and every sentence in the entirety of the internet.
Yeah.
Now, what if you said, I've always seen the word tree as the third word in the sentence X percentage of time,
Yeah.
right? You can
Yeah.
then start saying, okay, the word tree or the word apple, you can numerically encode, oh, I've seen this word in this sentence over the entirety of the internet 60% of the time,
Yeah.
80% of the time, 10% of the time. Now you're starting to embed context of the word, the position of the word, how it's seen it, its memory of that word over time. So now if you have 4,000 of these columns, every single one of these columns has some memory or
Yeah.
context about how it's seen the word, the way the word's been used,
Mm.
all of these things numerically associated for the entirety of that word of what it's seen it, right? This is the features, this is the weights of that word. And so this kind of creates, if you can think of visually, this pattern, right?
Yeah.
Of,
Yeah.
okay, whenever I've seen the word apple, has it always been used in the context of being followed by tree or being followed by store? It may depend on when you think of the word apple, you immediately, your mind goes to a couple things. You're like, oh, if you say an apple, the first thing I probably think of is tree. That's like the
Yeah.
closest thing I think of. But I might think apple pie too.
Yeah. Yeah.
And so you're like, oh, your mind immediately goes, an apple pie, an apple tree seems fairly closely related.
Yeah.
But what if the context of your conversation was we were both talking about, let's say, an iPhone? Then immediately when I say an Apple, your first instinct is an iPhone or
Yeah.
an Apple
Yeah.
something,
That's
right?
right.
Or an Apple store. That's because the context around it has changed. And so you might say, okay, we know if I just say with no context an apple, the most closest thing you're going to think of is a tree, maybe an apple pie. Further down, if you see like a grid, you might think, oh, like an Apple store, an Apple iPhone. Or what if I said something like the apple of my eye? And then
Oh,
you're
yeah.
thinking, whoa, that's super. Like I would not have thought about that.
Yeah.
You could see that if we were talking about phrases or comments, or maybe someone you were dating, and I said an apple of, and then you start, oh, my eye
Yeah.
becomes pretty obvious. So the context helps you bring the relation.
Yeah. Even from a so I was gonna say even from a Bible context, the Adam's apple, that there is that as
Yes.
well.
Yeah. Yeah.
The
That's
almost
right.
like you can take it in any direction because Apple has been used so often as well, but it needs to understand every single
Yes.
pattern that can be created by it.
And so when you look at the transformer and how it works, it's going to take Apple, it's going to look at the context, and each of those columns changes these weights on, oh, you know what? I've seen Adam's apple,
Yeah.
always like you can embed a little bit of numeric value. It says, oh, I've always seen the word Adam before apple in context with words relating to throat,
Yeah.
all these like kinds of things.
Yeah.
Like these things get encoded in these features per this word. And
Yeah.
so if you can think about all of the different associations you may have, it gets built into these weights, right? These
Mm.
features. And for example, when I say something like an apple tire, you're
Yeah.
gonna go, "Wait a minute, what the hell is that?"
Is that a new
Because
company you
you're
starting?
like you're like, "I don't see any association. I don't know where that is."
Yeah.
Way far away from what I would see as the most, obvious way of that being a word associated with it.
Ooh.
So,
Is that
all
where prediction would come in as well? Because you know how
yes.
Midjourney. Okay, fair.
Yeah, then because then all of a sudden when you're like, "Wait a minute, an Apple tire is that would not be so low on your prediction
Yeah.
scale,
Yeah.
right? What is the context at which that would be higher on a prediction scale?" And so now you're starting to learn, I think, a little bit about how context and weighting and attention on these words and attention on the context surrounding it happens. And so
Mm.
if I were then say an apple tree and I were to pass an apple to transfer, its prediction is going to go tree is the highest likely value. But
Yeah.
of course, there are others. There's Apple Store, there's Apple Pie, there's Adam's Apple,
Yeah.
whatever these are, there are like different variations of predictions. And actually, this is where you start getting into have you ever seen in like LLM's temperature?
Oh,
Uh,
yeah.
you
Yeah.
can change your temperature.
That's right.
If you set it to 00, then it's gonna go immediately apple tree. Like, it's just gonna go to the one that's the most predictable.
Yeah.
But if you
Yeah.
change that, it allows some randomness. And that
Mm.
randomness might say the LM might just choose an apple pie versus the least not as the most predictable, not as the
Yeah.
least predictable, somewhere in the middle, and that gives oddly creativeness, right?
Yeah. Yeah, yeah, it's almost challenging to your point. We as humans are we are doing pattern matching at the end of the day, right? To what you said about an Adam, Apple, Apple Tree, Apple Genius, Apple Store. We're also only pattern matching in our minds as well. We're not really. I guess I imagine you do have that picture in your mind, but I was gonna take a rewind a bit. That tokenization thing that you mentioned about OpenAI, is that how you would identify between, say, Bard AI from Google, Meta AI, and all of that? Is the tokenization piece that makes them unique, or would there be a lot more in those LLM models that would make them different? Because I imagine people are dealing with, oh, should I go with Bard, Chat GPT? What am I looking at?
Yes, so every model can have a different tokenization. I am not as much in the weeds to know whether BART or Llama has a different tokenization standard. A lot of people have been, obviously, because it's OpenAI, have been using OpenAI's tokenization standard.
Right,
Um,
right.
but of course, you are correct. Like Llama could be using something very different. And so if you were to fine tune that model, you need to use their tokenization in
Yeah.
order to fine tune that model. There definitely are differences, and everyone
Mm.
can use something different.
I guess a step further from that also is that for people who may be looking at this going, people who create to what you said, HeyGen and all the SaaS applications that are being created around the AI element, they're using some kind of tokenization or at least sending a token as well, or that's just sending an API request. Like I'm trying to think from a perspective that we cannot peel the layer of LLM. We spoke about tokenization, attention, and we spoke about the fact that this is how those models are working. But when people say chat GPT versus all of that, does that come into this point or is there another
You
layer?
know, think about tokenization very simple. All it is taking parts of a language and converting it to a numeric equivalent. It's a dictionary. It's I have the word apple and the numeric equivalent is 17180. And
Right.
why is that needed? It's needed because what AI is nothing but multiplication, right?
Okay.
Matrix multiplication. So you need a way to multiply the words. You need to convert the language into numbers, and those
Yeah.
numbers then go through formulas and some sort of math. And that
Right.
math produces what you want. The reason why you can have different tokenization, for example, is let's say one model decides the way that OpenAI does their tokenization is not as efficient. For example, when you tokenize something, take the word like something.
Mm.
Something can be one word, but actually, if it gets tokenized, it may actually be two numbers.
Yeah.
Something actually could actually be two numbers in a breakdown. Or when you say multiple of something, like a good
Three
example
times, four times.
is have versus having,
Oh
right?
yeah. Yeah.
Have is going to be tokenized, ing is going to be tokenized. And so
Yeah.
then when you add multiply ing, then ing is the same token, but multiply will have its own token and you're putting them together.
Right.
So you want to like all it is taking these English or really it could be non-English or any data
Yeah.
particularly and making it numeric. And there are, by the way, special tokens
Right.
that
Okay.
the system itself knows about, right? Whether it's the end of sentence token to know when to stop, beginning or when something is beginning. There are padding tokens so that when a transformer goes through its multiplication, it actually does this sort of like matrix multiplication. It needs a even numbers to do its multiplication. So some words or some tokens end up being shorter than others. And so you got to go pad them with some tokens. And these are specialized tokens that are no ops in code,
Right.
right? And that's how tokenizing works. And again, like it's really just the first phase. It's really
Yeah.
just saying, how do I take this into numbers? Then all the magic math happens.
Mm. Yeah. Yeah.
Yeah.
How a lot of people talk about the fact that every time we ask a query to ChatGPT or any of these systems, it's a huge amount of cost in the background. And it's basically LLM systems, as we speak about. Clearly, from what you're saying, if you're collecting every possible word, every possible punctuation, making it a number, I can't even imagine how big the database would be to account for not just English, but multiple languages as well now, the translation in Chinese and Mandarin and Hindi and all of that. And you go, oh, wow. So now I just multiply that by the number of languages.
I,
Is that
I
sorry,
believe I'm just totally going off of memory, but I think it's like 5,000 something. Yeah.
5,000 languages that it can cover at the
No, no,
moment?
5,000 tokens is the English language
Right.
for
Really? Entire English language can you put into 5,000 tokens?
I don't know. Let me ask ChatGPT. Hold
How many tokens does it
on.
need? Let's do a live demonstration. ChatGPT, we need some help. How many tokens
Anyway,
do we
I
need
think
to
it's
put
like
in
something
multiple?
like 5,100, something like that I believe are the number of tokens
So
for the
why do
English
people say it
language.
takes a lot of power in the background for it to just come up with an answer? I'm just curious because a lot of people talk about the cost associated with running all this as
Yeah,
well.
yeah. Training it
Yeah,
and running it an inference. Yeah.
yeah. So is that because if just 5,000 tokens, and in my little mind, I'm thinking, oh, that cannot be that complicated to run, or is it more of a
Well,
compute for it?
tokenizing is super easy and super fast. Remember, that's literally like converting dictionaries, key values, like apples this number, trees this number, ing
Yeah,
is this number. That is super fast. That requires
yeah,
no computational cost. The computational cost comes in the transforming, which is it's looking at the context and saying it's doing the math essentially to like look at apple and
yeah.
say, look at all of the context and where I've seen the word apple, understand what it's doing, do all the multiplications and get out all the massive math together to then be able to change the weight accordingly and continuously do this over every single variation of text of the internet, right? So
Right,
it's not about the word itself but as a standalone, it's about the word itself in every context that's ever been seen on every single text on the internet, right? That's the compute part. That's the training part that is really expensive because you're going to take however many GPUs and try to parallelize this as much as
yeah,
possible. So you can take a single sentence and then do all that compute per word. And
yeah.
so if you can parallelize that and then have it all do its math and then go to the next one, go to the next one, go to the next one, that's a lot of compute power, right? That's a lot of
Wow.
cost. And also
Yeah,
when you run it at inference, which means you got to run in a runtime, you've got to take incoming text and then run all that through the model and say, yeah, what does this mean? Can I actually produce an answer that makes sense?
because that makes me think of the deployment of LLMs as well. What's involved in, because I imagine a lot of people who listen to either this podcast or in general want to understand AI and data more from a, that's great, ChatGPT is out there, OpenAI is out there, or Bard is out there. I want to make my own because we are all special after all. And what's involved in like this kind of LLM deployments, man?
I think it's two things. Before I switch to deployment, I would say that like making your own LLM, and again,
Mhm.
I'm going to make some predictions here, right? Which
Okay.
is, I think it's asinine. It's both for both good. Think about this. You remember when cloud first came out and
Mm.
everyone was like, oh, all these cloud providers are going to do this. We're going to create our own private cloud and we're going to do
Yep.
this. And then what ended up happening is everybody started shifting to these majority three or four. And
Yep. Yep.
that is where it ended up because it's really hard to manage and do cloud. LLMs are exactly the same. You see these people who are producing these open models, which is fantastic, by the way.
Mm.
However, I think at the end of the day, if you're an enterprise or you're anyone, like the cost of both either training something and then running it is going to be really expensive. And so ultimately, I think when it comes to these generic frontier models, like you're just going to start as an enterprise, you're just going to use theirs.
Yeah.
However, with that being said, I think the future, and a lot of the theme I'm getting up is the future, although there is going to be a generic kind of model, like these sort of generic that we see LLMs today, smaller models being focused on a particular area of expertise is going to start really making the difference. So
Yeah.
similar to the way you think about humans is if you ask Caleb to be a master mechanic of cars, I will fail miserably.
Mm.
Like
Mhm.
my area of expertise is cybersecurity, right?
Yeah.
Like I am not a mechanic.
Yeah.
However, I know enough about cars generally to understand the basics. But I think you're going to start seeing these smaller models created as experts in the area, and
Yeah.
you'll have a generic model that will help navigate and or determine who of your council is the one that which will do this. And so when the smaller models, I do expect people to start deploying and
Yeah.
building smaller models potentially themselves. That'll be interesting to see.
Oh, it's funny because I think I'm always amazed at how similar you and I think, because I'm actually on the works of making a video around the whole AI as a service war that's coming. If you look at, you mentioned the cloud players as well, they're already on it. Amazon has Bedrock, OpenAI from Microsoft's trying to do that as well. And so Google is also trying to make their platform available as a, hey, by the way, we all can also help you build your own, because they're known for big data anyways. It's the obvious choice most times to go make a prediction system on it. So I definitely feel, to exactly what you said, as to add maybe a third layer to that, that there's an as a service war. Like, where am I going to host my own AI? Private cloud comparison, public cloud comparison, whatever you want to say it. They're all going to go for that piece of the slice as well now.
So can I tell you, I want to tell you a little bit of some things that scare me a little bit. And I
Okay.
and and again, this is probably me being ultra paranoid, but the thing that scares me just a little bit is that when the more you get into this AI space, the thing that I always expected is like, oh, the more that you come to reality about like how this is not really that great or the reality. The problem is it's doing the opposite. We've not even been a year, I think, since GPT-3 came out, and this stuff is scary good, and it's accelerating hundreds and hundreds of miles an hour faster than I can even keep up with. And the thing that I think that scares me the most is not only do we know, for a fact this is going to change everything in the future, but the fact that in order to have this kind of model will become absolutely necessary. And the only people who can have the level of data and the
Yeah.
level of compute is going to be big players. And
Mm.
so like when I was thinking in my mind, I was like, you have to have the ability to have this to innovate. You
Yeah.
have to have this ability to build products. Like it's always been this pattern of big companies grow up, become behemoths, cannot move faster, cannot innovate, cannot do things. It spawns off these startups who then go and build these things. They innovate faster, do better. I just wonder if big guys are the only people that can really have the capability and money to run these things.
Yeah.
And I also start wondering if it becomes so smart that it is the only thing that really helps innovate and helps execute. Do startups actually end up being at a disadvantage from big companies?
Oh, I see what you mean. Yeah, because like the traditional way where starters always disrupted is that I always describe it as a chef knife versus a Swiss knife. Like a big behemoth has become like a Swiss knife. They have an answer for everything. You want,
Yeah.
just tell me what you want, I'll give you whatever you need. Where a startup would come in, hey, by the way, we have this Japanese chef knife and we do all this and all that. So they're
Yeah.
very specialized, but there's an obvious need for it. But to your point, if the primarily that, if I use that same analogy and go, if the Swiss Army knife is the AI, and you're going, what am I? Either I'm making my own model, which is basically is somehow better or is a complementary to the existing AI. I'm at a disadvantage at that
Yeah,
point.
these things, the bigger the brain this thing becomes and the smarter it is and the faster it can execute, you can create factories, right? And the thing about it is that if you're a smaller startup and you don't have access to this level of knowledge and ability, it will put you at a disadvantage, right? You
Yeah,
don't have
yeah.
the data, you don't have the compute, you don't have the access to these really large models that big companies actually do have access to. I don't know. I'm being a little paranoid. I'm thinking way, way ahead, but I almost feel like these big guys, this feels like there's this chance that they can flip that switch and turn it around, where
Mm,
actually the big guys are the ones with a lot of advantages to the startups, which will
yeah.
be really interesting.
I would say, at least in my mind, the silver lining is that, and I compare this to the whole cloud launch as well. When cloud happened, the way it was sold as well. Hey, imagine having access to the same amount of data centers that Amazon has at any given point in time. You can just go from a company in the middle of nowhere to this global company in a matter of minutes.
Yep.
That was scary for a lot of people. The people thought, oh my God, what are we going to do? And ultimately, the people who wanted to pay money for all of this were being pushed into the space because of, hey, we want to be innovative, we want to be there everywhere, we want to be quick. I feel, yeah, and this forced the cloud service providers to make it cheaper and cheaper so they can go for more volume. I wonder if similar context over here, and maybe this is the silver lining I'm hoping for, just being the, as my wife would call it, the guy with the tinted glasses. I was like, oh, I feel there's definitely hope for the fact that if the big players need volume, they would have to be consumer friendly, which is whether it's your enterprise, startups, whatever, affordable costing, which probably to your point may mean there's an abstraction layer of, okay, so this much has been covered by AI.
I do agree with you, but the conspiracy side of me
Yeah, fair enough.
says, says, wait, I guess competition will help in this is why
Yeah.
not offer just inferior models,
Oh,
right?
yeah.
And
Or
so,
do what
like,
happened.
what we get from OpenAI versus others are not going to be what they get. And
Yeah.
so there's a lot of muting of and controlling of the data and capabilities and access that you
Yeah.
have
Yeah.
versus the big guys have restricted access. Hopefully competition forces that, right? Meta is like throwing all this stuff out for everybody, which is forcing these others. But then there's this regulation, safety, government, like now does it become controlled where all of a sudden you can't go do that because
Mhm.
of the negative effects of this. And then that forces a constraint around, oh, there can be areas where you're offering inferior models to everybody while you
Yeah.
have the capability to execute far more. So that's my conspiracy. Anyways, like we went way off topic.
Well, we should talk about what's hot in your mind at this point in time. I think we'll cover the implementation and the enterprise use case in the next episode. So maybe what's your hot topic for the week for AI?
My hot topic is I've been researching really two things. I've been researching Open Interpreter, which
Okay.
is basically you give it root access to your machine. It also does it on desktop. So you can do it on your OS X or your
Oh
Windows
wow.
X, right? And you give it full internet. And you basically, the way I've been playing with it, I just do a Open Interpreter dash Y, which means you just make decisions and you just run. Obviously, you do this in a sandbox for testing,
Yeah,
but
I was gonna say, yeah, hoping you're using a
this
virtual
thing
machine
is
or something.
it's crazy. Like, when you start watching the ability very similar to I feel like when I first saw like Auto GPT, it's like when you start seeing it, the reasoning capabilities around what it does. I'll give you an example. This is a really simple one. What annoys me and frustrates me about GitHub projects all the time, you have to clone it, you have to run it, and of course, you've got some dependencies that they're missing, and it didn't work
Mhm.
the right way, and they don't offer Docker container for it, and just all this like other
Yeah.
stuff. And you have to go through all these things. And when you finally get it running, it probably errors because you missed some configuration somewhere. And it's just
Yes.
like constant, oh, like it's just painful. So I was like, okay, let's see what this thing does. So I was like, I just took a random and a pretty actually advanced GitHub repo project. And I said, I want you to install this and get it running. And that was it. And I pasted the link. And it just went and said, okay, I'll figure this out. And it says, first, let's clone the thing. Okay, let's run the, oh, it ran into an error. It seems like this, it's missing this. Let me go and install the right things to install that. Oh, it ran into an error there. Okay, I can fix that. And it fixed it. And it gets everything like cloned, installed. And then it tries to run. And then it goes, this is the full, it says, okay, when I'm in the directory, it doesn't look like there's an obvious place to run it. But based off of the README and the files, it looks like these are probably the most, let me run it that way. And it runs it. And you're like, oh, yeah, that works. And it's missing this parameter. It looks like it's really looking for this. Do you want to provide it? Do you want me to provide it? And it
Oh
was
wow.
just like, and I did nothing. All I did was that first thing, did it. And it just went through everything.
Oh
And,
wow.
and it's just nuts. And it works on OS X too, which I
Wow.
haven't had the guts to do this
Yeah.
yet.
Yeah.
But
Oh my
like
God.
I'm setting one where you can just tell it and it will go through. It says, I've read your email. I'm adding this calendar entry. I'm changing your wallpaper today. It just does all this stuff and it just takes actions and makes decisions. It's just mind blowing. Like the thing is crazy.
This
And
is
so when you
crazy.
think about it, can I tell you a little bit of what this brings my mind to? I'm going future here, but
Yeah,
like
yeah, yeah.
when LLMs go into making decisions and acting, think about this. We've always talked about in security self-healing,
Yeah, yeah.
right?
Yeah.
Where, hey, when you see a security incident, how do you respond to it? Or if an application errors, how do you restart it
Yeah.
or get it back in a working condition? And you could see if we ever get to the point where smaller LLM models can run independently on any compute instance, on any instance in a container,
Like
it
an
could
agent.
just watch apps. It could see things happening and make decisions and respond to it in real time, right? It's a little bit like if you think about a security team today, it's very centralized to the aspect of a fire station
Yeah.
where,
Yeah.
hey, we see data that comes from a server. Oh, that's an incident. I should respond to that incident. You send somebody out who goes and says, what's going on in this instance? How's it happening? What if that can just be thrown into this LLM agent that actually real time inspects this data, sees the state of the application, what's expected, sees it, responds to it,
Yeah.
kills attackers, restarts software? Like all of that is like in a year, totally viable,
Oh,
right?
wow. In a year.
I think totally viable in a year. If there's not a
Ooh.
startup already working on how to take first, I think the technology gets to the point you need to make a model small enough with at least amount of compute that it can run in a running
Oh,
service,
yeah. I
right?
mean, yeah.
Being able to analyze and understand and make decisions in real time I think it's definitely going to happen. Because when you watch it decide,
Yeah.
operate, and make changes on its own, you just let it run. Like it's pretty smart, man. Like
Yeah.
it's
Yeah.
I could see a point where when you start thinking about cybersecurity, this stuff really starts getting into some interesting territory.
Because as you were saying, this the obvious model that I know of is the agent-based model that a lot of people use in virtual machines. But to your point, it doesn't have to be an agent as well. People don't need to limit themselves with what they think of agent as, because there's a lot of things you can find just from API calls these days as well. You don't have to
Yeah.
even have an agent. So if someone thinks of this as a company after they hear this, please reach out to Caleb and give some revenue share to him for it as well. But I definitely agree with you. I also agree on the fact that I'm curious to see how we always watch a movie which is very futuristic. You walk into a room, lights turn on. You do things which happen automatically because you have told Alexa or whatever to say, every time I walk in the middle of the night, I want the lights turned on in a certain dim set setting. The same happening to your computer, to what you said about the open interpreter. I imagine in my mind, you wake up, you get a coffee, whatever, you walk into your home office, lights turn on, computer turns on with, hello, Caleb, welcome to, I don't know, whatever the date, 6th of October, 2023. Today's calendar looks like blah, blah, blah. You have your calendar on the side. And it's almost like making calls for the fact that, oh, by the way, I noticed you have a gym appointment later today. You should make sure that you actually have this finished, blah, blah, blah. Does everything.
All that's doable today.
Yeah.
You can do that today. You can make it happen.
Oh, oh
Like
my God.
it takes some
That's
elbow grease, but like today, I think that's super doable.
Oh my God.
Yeah,
Well, I'll quickly do my hot topic as well. My hot topic was the Meta AI announcement that happened for. So they already had a version of Ray-Ban last year that they had announced. They came up with the updated version of Ray-Ban. This time it's integrated into the Meta AI and it allows people to do live stream. It allows them to see an object and interact with Meta AI live in within their, imagine Iron Man glasses. But the fact that you can look at an image and ask questions about it. You can find help on how to fix a faucet leak, things like that. Basically, there's a leak happening. You can just go, oh,
yeah,
I don't know what to do about this, or what's the right temperature for chicken on a barbecue? I don't know. Like,
yep,
it definitely get into a point. But one point that was really fascinating, and maybe this was my moment of being scared, was that you could have live stream on your Ray-Ban. But from a looks, it looks exactly like a Ray-Ban. There's no difference apart from this tiny ass camera on the corner, and the person just starts the live stream. You don't even know you're part of a live stream as you're standing and talking to your friend. That part to me is a bit makes me a bit nervous because which conversations are going online. A lot of trust is probably built with people interacting and doing all of that, and that being kept private. And now that's open on the internet potentially as well. I don't know what you feel about technology like this kind of being made
Well,
available.
we went through this with Google Glass, right?
Oh
And
yeah, yeah, that's right.
and I do think that the one thing they're definitely gonna do, if it's not already in there, is you will have to have a light indicating you are live recording. That is absolutely necessary, and if it's not in there, like, similar to Google Glass, like, one, people didn't really appreciate the sci-fi nerd look.
Mhm.
As
Yeah. I mean, at least this one looks like a Ray-Ban glass, so
and
it
this
didn't
looks like
look like
Ray-Ban glasses, but at the
yeah,
same time, like, people really got creeped out when talking with someone because they didn't wanna be recorded. There is an assumption of privacy when
yeah,
you and
yeah,
I are physically sitting there and talking, and I think that assumption of privacy now has to be made readily known through those Ray-Bans, right? Which you're not gonna you either will take them off when you're
yeah,
talking. However, I do think, like, they'll probably just put some indicator that'll say live streaming, right? Now, putting an indicator to say whether it's running or not probably won't happen because you'll wanna do stuff like wear it. For example, I am terrible at remembering people's names, right?
mm.
It's a horrible trying to work on it too, but it's
Oh,
horrible.
yeah,
It's just
same I'm the
you
same
don't.
as well, yeah.
Yeah, and so when you walk up, you're gonna can you get the facial recognition, shows the LinkedIn profile. "Oh, yeah, the last time we talked." That is and say, "Oh, hey, Ashish."
Yeah,
Boom, boom, that helps. That thing isn't necessarily recording actively, although it is working actively.
yes.
So, that'll be my guess.
Yeah. Okay. So there, I think for from what they showed, there is a lens that opens up, and it does have a bit of a gray area. That at least, okay, maybe to be
Got
fair,
it.
it was a zoomed in view, so I don't know if how obvious it is because people who wear glasses would not see it for sure. It's like tiny. Imagine how small the screw is on a Ray Ban. If that's the size of this camera, you're not really recording or you're not noticing at that point in time. But I'll be curious. I'm hopeful it's a better world, but that was mine.
Can
But
I
I'll
can I also tell you, I think you're fighting it. Yeah, but it's gonna happen.
I think that's what
It's
people keep
gonna
telling me.
happen.
It is
No,
happening. It is
like, there's
happening.
gonna be a time where I think we're just walking around and everything is just being recorded. I just think it's unavoidable.
It already happens. Like police does it. Like at least in London, the CCTV cameras everywhere. That's always live, and you're always in a camera somewhere. Just there is no safety from it. But
There's no
you
safety.
almost have that trust. It's a police. But this time, it's your friend. It's people at the bar who could be anyone. But my
If I add a little bit of security to our, I feel like predominantly non-security talk, I do think one lesson that we have learned as security people is always this convenience trumps safety and privacy. And
oh yeah,
this is exactly this. If they make these things convenient enough where it just makes no sense for it not to be a recording,
yeah,
privacy goes out the window, uncomfortableness, like all that safety goes out the window because that's what people will want to do. They'll want the convenience. And as
yeah,
soon as the majority, just like Apple, remember when AirPods, people are like, "Oh, that's super weird. No one's going to
yeah,
wear that." And
yeah.
it's like, well, and then it like ever, and then fashion celebrities started, then everyone started wearing it. And then people started, "Oh, like it's super convenient. I'm just gonna," and it was done.
Oh my god. Oh wait, I feel like it's the same as the. Have you seen those the sling bags that people carry?
Yes.
I'm like, I find that thing to be the most weirdest in the world. Like, I'm
You
like,
I totally am with you, but you know what? I'm excited that it's becoming an end thing because it's super convenient. It's a man purse, man. Like, you can store things in it. Like,
yeah,
what's also weird is there's this weird dichotomy, I feel like, where it's like, when everything is I'm trying my best to get everything in my life into a phone,
yeah,
so I only carry one thing, right? Like, I shouldn't have to carry my driver's license, credit cards go to Apple Pay, whatever these things are, it should all go to one device, but yet what's becoming fashionable is now the thing at which I can carry multiple things.
yeah, 100%. We should, to your point, we should come back to the cybersecurity part as well. But I might draw a line for this episode over there because I think you and I can talk for hours. If anyone is interested in having a question answered from an AI cybersecurity perspective, feel free to reach out and drop us that in the comment section if you're watching this on YouTube or on audio. But thank you so much for your time, Caleb. Until next episode, where we talk about LLM implementation and the enterprise version of what it may look like in the LLM. Awesome. Thanks, everyone.